Ellipses have something called eccentricity, which has to do with the distance from the center to a focus and the distance from a center to a vertex. So there's more information about that in the textbook if you would like to see it. Here's an application of an ellipse. As with parabolas, ellipses have a reflective property. Sound waves emanating from one focus reflect off the top of the ellipse and head toward the other focus. Such geometry is used in the construction of whispering galleries. If a person whispers at one focus, a person standing at the other focus will hear the other person as if they were standing right next to them. Shauna and Spencer want to exchange secrets from across a crowded whispering gallery, which is a room having a cross-section that is half of an ellipse. If the room is 40 feet high at the center, so that point right there we could say is at 0, 40, and 100 feet wide on the floor, so we could say that this point here is at negative 50, 0, this point is at 0, 0, and this point is at positive 50, 0. How far from the outer wall should each of them stand so that they will be positioned at the foci? So there's a foci, just approximately where they're located, so just so we can see what we're trying to find. So let's start by writing an equation. We've centered it at 0, 0. So x squared over our x distance would be 50 squared. And then y squared over our vertical distance would be 40 squared equals 1. Now to find c, we would take those two numbers, 50 squared, and subtract 40 squared. So using my calculator, that would result in 50 squared, which is 2,500, subtract 1,600, which gives me the square root, I believe, of 900, right? And that gives us a distance of 30. So keep in mind that this is the 30 here. So the distance we're finding is this distance here, which will be 20. So how far should each of them stand from the outer wall to be standing at the foci? They should be standing at 20 feet from the wall.